aviation industry is standing at a turning point, and one of the most ambitious concepts pushing it forward is the JetZero Z4, a next-generation blended wing-body BWB airliner. Unlike the conventional tube and wing aircraft that have dominated commercial aviation for more than 70 years, the Z4 represents a complete rethinking of aircraft design, efficiency, and passenger experience. With the increasing global demand for air travel, combined with urgent concerns over climate change and fuel consumption, this innovative design could be the key to redefining how we fly. In this article, we will explore the history, design, technological advancements, sustainability potential, and future applications of the JetZero Z4, while also understanding why it has captured the attention of both the aerospace industry and the U.S. Air Force. The origin of the blended wing body concept. The idea of a blended wing body is not new. NASA, Boeing, and several research institutions have been experimenting with such designs since the 1990s. The BWB concept merges the fuselage and the wings into a single, seamless aerodynamic shape. Unlike traditional aircraft with a cylindrical fuselage attached to long wings, a BWB aircraft has a wide, flat body that acts as both the fuselage and lifting surface. This design reduces drag, improves lift-to-drag ratios, and creates opportunities for more spacious cabin layouts. While experimental models like NASA's X-48 demonstrated the feasibility of such designs, no commercial passenger plane has ever been built in this configuration. The primary barriers have been technical complexity, certification challenges, and hesitancy within the industry to move away from proven tube and wing models. JetZero, however, is determined to overcome these barriers and bring a BWB aircraft into service. JetZero and the Z4 vision. JetZero, a California-based aerospace startup, was founded with the mission to revolutionize commercial and military aviation through innovative design. The Z4 is its flagship project, a medium-sized blended wing-body airliner designed to carry around 200 passengers on medium to long-haul routes. What sets JetZero apart is not just its ambitious design, but also the partnerships and support it has secured. In 2023, the U.S. Air Force selected JetZero to advance the BWB program, providing financial and technical backing. This collaboration ensures that the Z4 will not only aim at commercial airlines but also military uses such as cargo transport and aerial refueling. With this dual-purpose approach, JetZero is positioning the Z4 as both a sustainable passenger aircraft and a versatile military platform. Design features of the Z4. The most striking aspect of the Z4 is its blended wing-body design, which makes it instantly recognizable compared to today's airliners. The seamless merging of fuselage and wings allows the aircraft to achieve aerodynamic efficiency levels unattainable by conventional designs. According to JetZero, this design could reduce fuel consumption by as much as 50%, a dramatic leap forward in efficiency. Another notable feature is the engine placement. Instead of being under the wings, the Z4's engines are mounted on top of the rear fuselage. This configuration provides multiple benefits. It reduces drag, shields ground communities from noise pollution, and allows for cleaner airflow across the wing surface. The noise reduction aspect is particularly important as aviation faces increasing pressure to minimize its environmental footprint not only in the air but also in the communities surrounding airports. Inside the aircraft, the Z4 promises a radically different passenger experience. The wide, open interior of a BWB design eliminates the narrow tube feel of traditional aircraft. This allows for new seating configurations, more spacious cabins, and potentially even amenities such as lounges or workspaces. The futuristic design could completely redefine passenger comfort, efficiency and sustainability. Perhaps the strongest argument in favor of the Z4 is its sustainability potential. Aviation currently accounts for about 2–3% of global carbon dioxide emissions, and demand for flights is only increasing. Airlines are under immense pressure to cut emissions, and governments are pushing stricter environmental regulations. The Z4 addresses these concerns with its superior aerodynamic efficiency and reduced fuel consumption. A 50% reduction in fuel use compared to current generation airliners translates not only into significant cost savings for airlines but also a major reduction in carbon emissions. Moreover, JetZero is designing the Z4 to be compatible with sustainable aviation fuel (SAF), a cleaner alternative to conventional jet fuel. In the long run, the aircraft may also be adaptable to hydrogen propulsion or hybrid electric systems. This flexibility ensures that the Z4 will remain relevant as propulsion technologies evolve. Range and performance. The Z4 is expected to serve medium to long-haul routes, with the ability to cover transcontinental distances. While exact performance specifications have not been publicly finalized, early projections suggest that the Z4 will be competitive with existing narrowbody and midsize widebody aircraft. Its passenger capacity of around 200 seats places it in a category similar to the Boeing 757 or Airbus A321XLR, but with vastly improved efficiency. For airlines, this means the Z4 could become the ideal aircraft for high-demand medium-haul routes, as well as offering the possibility of opening new, thinner long-haul markets thanks to its lower operating costs. Military applications. The U.S. Air Force's involvement in the JetZero Z4 program is a clear indication of the design's military potential. A blended wing-body aircraft can serve as an aerial tanker, cargo plane, or even a long-endurance surveillance platform. Its large internal volume allows for greater fuel or cargo capacity, while its aerodynamic efficiency extends range and reduces operational costs. By supporting JetZero, the Air Force is also helping accelerate the technology's development for commercial aviation. This dual-use strategy reflects the broader trend of collaboration between military and civilian aerospace programs. Challenges ahead. Despite its promise, the JetZero Z4 faces significant challenges before it can enter service. Certification will be one of the biggest hurdles. Aviation authorities such as the FAA and EASA have decades of experience certifying tube and wing designs, but a blended wing body represents a new category. Safety standards, evacuation procedures, structural testing, and aerodynamic assessments will all require new approaches. Passenger acceptance is another question. While the futuristic interior may appeal to many, some passengers might be hesitant about flying in an unfamiliar design, particularly if seating layouts place passengers far from windows or facing unconventional orientations. Overcoming this perception barrier will be essential. Additionally, building such a radically different aircraft at scale will require new manufacturing techniques, supply chains, and infrastructure adjustments at airports. These challenges, however, are not insurmountable, especially with strong financial and governmental backing. The timeline. JetZero aims to have a full-scale prototype of the Z4 ready by 2030. This timeline is ambitious, but with the U.S. Air Force partnership and growing interest from airlines in sustainable solutions, it is realistic. Smaller-scale demonstrators are already in development, and these will play a crucial role in proving the design's viability. If the timeline holds, the 2030s could mark the beginning of a new era in aviation, one where blended wing-body aircraft finally take their place alongside or even replace conventional airliners. Industry impact. The introduction of the JetZero Z4 could have ripple effects across the aerospace industry. Competitors such as Boeing and Airbus have long studied BWB designs but have yet to commit to building one. If JetZero succeeds, it could force the major players to accelerate their own efforts in order to remain competitive. Airlines, too, would need to adapt. The efficiency gains of the Z4 would make older aircraft economically obsolete, pushing carriers to invest in new fleets more quickly. Airports may also have to adjust, as the wide-body shape of a BWB aircraft could require changes to gates, jet bridges, and taxiway layouts. A symbol of the future. More than just a new aircraft, the JetZero Z4 represents a vision of the future of aviation. It symbolizes the willingness of innovators to take risks and break away from decades-old traditions in pursuit of a more sustainable, efficient, and passenger-friendly future. If successful, it could become the blueprint for a new generation of airliners, reshaping the skies for decades to come. Conclusion. The JetZero Z4 is not just another aircraft, it is a bold step into the future of aviation. With its revolutionary blended wing-body design, promise of 50% fuel savings, adaptability for sustainable fuels, and dual commercial military applications, the Z4 could be the game-changer the industry needs. Challenges remain, from certification to passenger acceptance, but with the support of the U.S. Air Force and the growing global demand for sustainable aviation, the Z4 stands a strong chance of success. As we look toward the 2030s, the question is not just whether JetZero can deliver the Z4, but how this aircraft might change the very way we think about flying. If it succeeds, future generations may look back at the tube and wing era as a stepping stone to the truly modern age of aviation, an age ushered in by the JetZero Z4.